In this video, we're going to talk about how to perform operations with decimals. So first, let's talk about adding and subtracting decimals. So to add and subtract decimals, you're going to rewrite the problem vertically and make sure to line up the decimals. Then you want to bring down the decimal so that it's in your final answer and add or subtract as you normally would. So if we're adding 5.436 and 2.754, we're going to go ahead and rewrite this vertically. And what we're going to do is we're going to put the decimal in the same respective place in our answer. Now we're just going to go ahead and add these numbers together. So 6 plus 4 is 10, carry 1. 5 plus 3 is 8, plus 1, so I have 9. 4 plus 7 is 11, carry 1. And then I have 5 plus 2 is 7, and then I add my remainder, so I get 8.190. So remember, we usually don't include lagging zeros in our final answer, so 8.19 is actually the correct way to write this answer. So let's try adding 3.576 and 8.2. So I have 3.576 and then I write the 8.2 with the decimal in the same place. So notice that these two don't match up because I have some extra digits in my top number. But what you can do is you can add these zeros in at the end as a placeholder just so you can see that everything lines up correctly. So we have 6 plus 0, so that's 6. 7 plus 0 is 7. 5 plus 2 is 7. And then I bring down my decimal. And 3 plus 8 is 11. So we have 11.776. So now let's try subtracting decimals. So basically it's the same idea. We're going to rewrite this problem so that the decimals are in the same respective position. And then we're going to go ahead and subtract. Remember, we can add in that 0 as our placeholder. So we have 1 minus 0, so that's 1. 6 minus 4 is 2. 8 minus 2 is 6, and bring down the decimal. And then 9 minus 5 is 4. So we have 4.621. So now let's try subtracting these two numbers. Well, I want you to think about this for a second. Notice that we're actually taking a smaller number and subtracting a bigger number. So let's think about what we talked about when we were talking about subtracting integers. So remember we said if we have a smaller number and we're subtracting a bigger number, we know that our answer is going to be negative. So I can actually think about this as like 142.07 plus negative 265.3. So remember, when we're having an addition problem like this and the two numbers have opposite sign, technically what we're going to do is we're going to subtract the numbers, right? And then we're just going to add in the sign as negative because the bigger number is negative. So actually, I'm going to use that idea here to go ahead and subtract it like this. So I'm going to do 265.3 minus 142.07. So once again, you can see here I have a digit missing, so I'm going to add in my 0, and now I'm going to subtract. So I need to borrow 1, so I'm going to make this 10, and then this is going to reduce to 2. So 10 minus 7 is 3. 2 minus 0 is 2. Bring down my decimal. 5 minus 2 is 3. 6 minus 4 is 2. 2 minus 1 is 1. So 123.23 is my final answer. But remember, I need to make it negative because in my original problem, I was taking a smaller number and then adding it to a bigger negative number. Okay, so now let's try multiplying decimals. So to multiply decimals, what you're going to do is you're just going to multiply without the decimal points, and then you'll count how many digits are after the decimal in the original numbers, and then use that to determine where the decimal goes in your final answer. So let's see what that looks like. So suppose we're doing 6.45 times 3. I'm just going to multiply it as though it's 645 times 3. So I'm do 5 times 3, so that's 15, so I carry 1. 4 times 3 is 12, plus 1, so I have 13, and then carry 1. 6 times 3 is 18, plus 1, so I have 19. Okay, so I need to think about where my decimal is going to go. I have 2 digits after my decimal in the original problem, so I'm just going to go here, and I'm going to go 1, 2, and I have 19.35 as my final answer. So now let's try multiplying this problem. We have 7.21 times 4.3. Once again, I'm going to go ahead and multiply as though there's no decimal in this problem. So I'm just going to do, let's see, 1 times 3 is 3, 2 times 3 is 6, 7 times 3 is 21. And then I do the next row, so I'm going to add my 0. 4 times 1 is 4, 2 times 4 is 8, 7 times 4 is 28. And then I go ahead and add these numbers together, so I have 3, 0, carry 1. 8 plus 1 is 9, 9 plus 1 is 10, so carry 1. 8 plus 2 is 10, plus 1 is 11, so I carry 1. 2 plus 1 is 3. Okay, so now notice in my original problem, I have 1, 2, 3 decimal places. And so I need to go ahead and move my decimal 1, 2, 3 places. So I have 31.003 as my final answer. So now let's try dividing decimals. So to divide decimals, you always want to make sure that your divisor is actually a whole number. So the divisor is going to be the number that you're dividing by. So how do you do this if it's not already a whole number? Well, you want to multiply by a power of 10, but when we're working with decimals, when you think about multiplying by a power of 10, What you're really trying to do is you're trying to move the decimal to the right. So let's imagine I'm multiplying both of these numbers by 10. Okay, and I'm allowed to do that as long as I multiply both numbers by the same value. Well, when I do that, I'm actually going to be able to move my decimal to the right one place, and that's going to help me turn my divisor into a whole number. So this is actually 320.4 divided by, now it's going to be 6. So I'm going to go ahead and set up my division now. So I have 320.4 divided by 6. And what I can do is I can just divide. So 6 goes into 32 5 times. Subtract 30, so I have 2, bring down 0. And then 6 times 3 is 18. Subtract, and then I get 2. And then I'm going to put the decimal in the same respective place. And then I bring down 24. Bring down 4 to get 24. And then 6 times 4 is 24. So when I subtract, I have a remainder of 0. Okay, so 53.4 is going to be my final answer. Okay, so I just want to show you this is an important application of how we use the ideas of dividing decimals. Suppose you have a fraction and you need to convert it to a decimal. How do you go about doing that? Well, you can kind of think about it as a decimal division, and I'll show you why. Because if we're doing 5 divided by 8, okay, obviously we know 8 doesn't go into 5. So what we'll have to do is we'll have to add a point here, right? And then we add a 0. Because remember, we can keep adding any number of lagging zeros that we want after a decimal, and we won't change the value of the problem. So I'm going to put the decimal in the same respective position, and now I'm thinking about 8 going into 50. Well, how many times does 8 go into 50? It goes in 6 times. 8 times 6 is 48. I subtract, I bring down the 2. And remember, I can keep adding zeros until I'm done with this problem. So I bring down 0. How many times does 8 go into 20? Well, it goes in 2 times, right? 2 times 8 is 16. And then I subtract, and then I get 4. Can add another 0, so I can bring down 0. And then I have 8 goes into 45 times. So then I subtract 40, and I'm left with a remainder of 0. Okay, so that means 5/8 as a decimal is 0.625. If you want, you can add the leading 0 in if you like to write it that way. Okay, so remember, when you add and subtract decimals, you're going to write the problem vertically, line up the decimals, place the decimal in the answer, and then add or subtract. When you multiply, you're going to multiply as though they're whole numbers, and then count the number of decimals in the original numbers and move the decimal in the final answer that many places left. When you divide decimals, you're going to multiply both numbers by a factor of 10 to ensure the divisor is a whole number, place the decimal in the quotient, and then divide.